screen. Just keep in mind, I can usually see everything. So just
All right.
sensitive stuff, keep off to the side. All right, so yeah, so find the quotient. Got it. All right, so this one I'll snip and we'll work through it together. I will share my screen. Okay. All right, so I'm sharing my screen now. One of the things that I'll remind you of here is that division is really multiplication by the reciprocal.
Yeah.
So we're going to write this as 2xyz, x cubed, z cubed. And then we're just going to flip this. So it's 2x squared, z squared over 6y to the fourth. And probably the best thing to do here is to try to make one fraction by combining everything in the top and then everything in the bottom. Okay, so you got 2 times 2, that's 4. When you have the same base, like x and x squared, you add the exponents. Okay, there's no y, so we'll keep it as y. It's z to the 1, z squared, that's z cubed. At the bottom, there's really a 1 there. 1 times 6 is 6. X cubed doesn't go with anything. Y to the fourth, there's nothing go with there. And then z cubed also down here. All right, so from here, this is kind of the fun part. You cancel out stuff that divides. So like, do you see that there's the same number of x cubes in both cases?
Oh yeah, okay, I remember how to do this now.
Same thing with the z's, it cancels. Y, there's 1 up top, 4 on the bottom, so that means there's going to be 3 left over on the bottom. And then 4 and 6 divide by 2. So this is your final answer, and that's what they're looking for in this first box here.
Okay.
And then in terms of what x cannot equal and z cannot equal, because they completely went away, it's 0 in both cases.
Oh, I put in squared. That's why I got it wrong. Okay.
Great. So we got another kind of thing like this, really similar, but I'll grab it and then I'll share my screen here and take a look. Share screen. Okay. So again, kind of this turns into multiplication, and then you flip this thing over here, 4x cubed and then x plus 2. Okay, so you flip that. On the top left, you can actually factor this. So you're looking for 2 numbers that multiply to -6, but then add up to -1. So that's like -1 and 6. 1 and -6, -2 and 3, 2 and -3. Do any of these 4, excuse me, do any of these 4 add up to -1?
2 and -3.
Yes. So it becomes x plus 2, x minus 3. And I'm going to try and save from writing a bunch of stuff today by doing it this way. Now, the bottom one has a GCF. And the GCF is 2, because 2 goes into both 2 and 6, and then it's the smaller exponent, so x cubed. And then you figure out what is left over on the inside here. Okay. So if you were to multiply that in, you would get back to the original, and that all goes down here in the bottom. Okay,
And
so
I have to factor?
you absolutely have to factor. Yes.
Oh, excuse me.
It's like when you reorganize a room or a drawer, you have to take everything out. It gets worse before it gets better, and it's about to get better. But the reason you factor is because things are about to cancel. Now, you can cancel vertically. I'll write that here. You can cancel vertically and diagonally here. Okay, so like see how this x minus 3 goes with that x minus 3?
Yeah.
Okay, this x plus 2 can go with this x plus 2. And then the x cubed on the top right goes with the x cubed on the bottom left. So this all reduces to 4 over 2, but 4 over 2 reduces to just 2.
All of this just equals 2?
Yes, do you want me to show you the cancellations again?
Yeah.
Because that's the important part. Okay, let me grab this. Okay, we'll try it one more time here. Okay, so let's do this differently. What do you see that is the same on the top and the bottom?
X minus 3 and,
So those go away.
and x plus 2.
So those go away.
And then x cubed.
And then this 4 and this 2 becomes just a 2 and a 1.
Okay.
Okay, now,
Well, that's easy part.
yeah, so now to figure out what goes in each of these 3 boxes, whenever you cancel something in the top and the bottom, you're going to fill something in here. Okay, so here's what we cancel in the top and bottom. You said this x minus 3, x plus 2, and then the x cubed. Excuse me. So set each of these not equal to 0. Okay, and for example, if you add 3 to both sides, you get x cannot equal 3. If you subtract 2 from both sides, you get x cannot equal negative 2. And the last one here, there's actually nothing to do. You just take a cube root of both sides, but x cannot equal 0. So whenever you cancel out, that's what leads to these boxes where it's not equal to.
Okay. Got it. Cool.
Great, another one, just just like the
So
last time.
fun.
Yeah, it's very repetitive. I mean, it's good practice, but it's very time consuming because there's lots of steps each time. All right, so let me share my screen. All right, so as I mentioned, you always turn this division into multiplication. This time I'm just going to use a dot, okay? And then you end up flipping these. So do you see how the 3x minus 3 would go up top here? So we actually would want to factor out before we do that. And then the 3 times x minus 1 goes up top. The 2x goes on the bottom. So you change division to multiplication by the reciprocal. The top left here is a GCF. Can you tell me what the GCF is between 2x squared and 12x? Like what number goes into both of those? 2. And then between x, just
2x
x
times x minus 6.
Perfect.
Okay,
yeah. So that goes into the numerator. And then the denominator here, you look at 6, this last number here, you're trying to find 2 numbers that multiply to negative 7. Do any of these multiply to add up to negative 7?
-1 and -6.
Yeah, x minus 1, x minus 6. The other thing, and you've probably started noticing this, you should be getting things that are going to cancel. So like if you're having a hard time figuring it out, like see how there's now an x minus 1 and an x minus 1 and an x minus 6 and an x minus 6.
Yeah.
You're supposed to get stuff that cancels. So it's not a guarantee of how to do it. It's just a helpful hint. So
Right.
what do you want to cancel first? What do you see that cancels?
X minus 1, x minus 6, and 2x.
Cancels with, and what's left over?
3.
Yeah. So here's what you told me cancels: x minus 6, x minus 1, and then 2x. So that's
And
x.
then it'd be, yeah, positive 6, 1, and 0.
Yes.
Okay, this one's a little bit different, but I feel like I might know how to do it.
Yeah, let me grab it. We'll work through it. Okay, on the right here, this is actually this whole thing over 1. So when you change it to multiplication, you're going to put a 1 up top. And then you're trying to find two numbers that multiply to 9 but add up to -6. Do either of these add up to -6?
-3.
Yes.
-3.
This happens to be what's called a perfect square trinomial, but that only matters if you're identifying these things. So now on the left, x plus 4, there's nothing to do there. But on the top, trying to find two numbers that multiply to -6 but add up to -1. So that's like -1 and 6, 1 and -6, -2 and 3, 2 and -3. I think we actually already did this one in a previous example. Okay. So if you can factor, and you can, and just maybe it takes a little longer, then you start canceling. So what do you want to cancel here? What do you see that goes away?
X minus 3.
Anything else?
No.
Yeah, so unfortunately, you're left over with x plus 2. You're left over with x plus 4 and x minus 3. And it's okay to leave it in factored form like this, but that is your final answer for this one. So it does not always produce a number. Sometimes it actually produces another quotient.
Okay. Okay.
All right. Okay. So in the past, you've asked me questions like, hey, can we, use Desmos or something for this? And the answer is no, because there's no answers to compare it to.
Mhm.
Unfortunately, if you want to do it by hand, this is the only way. There are definitely calculators out there that will shortcut this for you, but like the steps I'm showing you are really the only steps to do it completely. So this one's very repetitive, meaning it's we've done a bunch like it. So the top left here, it becomes x minus 9, x plus 4 over x plus 2 times, and then this becomes 1 over x minus 9, x minus 9. So would you mind trying, like figuring out what cancels and then seeing if you can get the right thing there in that box?
Mhm.
And let me know if you have any questions about that. Because I've already shown you a couple examples. This one's just like it.
Yeah. And would this it be added to 18 and multiplied to 81, right?
No. This right here becomes this over here.
Yeah.
So like whatever's left over when you cancel goes on the top, and whatever's left over when you cancel stays on the bottom. See how in the previous problem here we just ended up with stuff that was on the top and then on the bottom in blue?
Right.
It's the same idea here. Like, what are you going to cancel? What goes away?
X minus 9.
Okay, so what is left over in the top?
Um, X plus 4 over
Okay,
X plus 2 times X minus 9.
perfect. That's what goes in that box there.
Okay.
Okay. Do you mind just going to 7 and 8 just to see if these are kind of the same? Okay, same, same. Okay. Do you want, I mean, I have no problem for us to keep working through this, but do you want us to move on to another assignment, come back to this? Is the goal to get through it? You're the customer, you tell me what you want to do, but these are very much the same as what we've already done.
Right. I say we can come back to this since we only have like 3 more left, and
Okay,
I have some new stuff if we should work on that.
sure. It totally up to you.
Okay, let's do the new stuff. 7.5. No. Okay.
Okay. Yeah, we can do this. These are a little different. So all right, let me share my screen.
Okay.
Right. So the analogous problem here is one where if I asked you what is x divided by 2 minus 1 divided by 2, do you see how the bottoms are the same?
Right.
When the bottoms are the same, you keep the bottom and then you just rewrite the top. So here,
Oh, okay.
the bottoms are the same. So you keep it and you just write x minus 4 in the numerator. Now they do get more difficult from here, but that's the guiding principles. Like you can only combine stuff when when they're the same in the bottom.
Right. Okay. Cool.
So if the bottoms are not the same, which will likely be the case in the next problem, we will make them the same and then combine the tops. But here you can actually just do it without, any visual from me. That's just 9 minus 2x over x plus 1.
Same thing.
Yes. Eventually there will be a small little wrinkle, little change, but for now that looks good.
And x is not equal 3? What?
So go ahead and write, go ahead and do what you've been doing, but don't hit submit, please.
Okay.
Okay, so do you see that there's a 5 in the numerator that could be factored out of both on the right there, on the 5x plus 15, where you filled in the box?
I'm blind. I'm sorry.
That's okay. That's okay. I just want to make sure. So do you see that the top is, you could factor a 5 out of the top? And if you can't see it, I'm going to, so what I'd like you to do is go to the top, the numerator, and we're going to factor out a 5 there, just visually, or go ahead and type it. I'm sorry. Can you click in that space? So do 5 parentheses
3.
x plus 3. Okay. Now this is what I normally have been writing. And what would you do here when you see that there's the same thing on the top and the bottom? What did we do? I showed it in red often. Cancel. You get rid of them.
Cancel it, yeah.
Because
So
they're the
this
same.
is 5?
It's just 5. Yes.
What? Well, that's easy.
Well, it works out nicely. It's friendly, but they're
So
not always.
far, yeah.
It's not always like that. All right, let me grab this one to show you here. Thank you for trying to work that out on your own. I know it's hard when someone's giving you commands and
No,
saying,
you're fine.
saying like, "Hey, do this," and you're like, "What are you talking about?" All right, so this one here, the bottoms are the same already. And that's good. That's what allows you to combine them. So the bottom is 2x minus 1, but the top is 4x squared minus 1. So the top is what is called difference of squares. I think we talked about this last time, but it's this form. It's a squared minus b squared, and it factors to a minus b, a plus b. So what you have to do is you have to figure out what is your a and what is your b. Basically, like, what are you squaring to get back to 4x squared? And then what are you squaring to get back to 1? So like 1 squared gets you back to 1. So that means that your b is 1. Okay. What do you square to get back to 4?
2.
2. And what do you square to get x squared?
X.
X. So your a is 2x and your b is 1. So the top you write in this form, a minus b, 2x minus 1 A plus B, 2x plus 1. That gives you 2x minus 1. These cancel. And what are you left over with?
2x plus 1.
Yes. Okay, so let's work this out. To go ahead and type in what you think the answer is. So 15 plus 5, what is added up to, though? You can do that mental math.
20.
20 over 4x. And then is there a number that goes into both 20 and 4 that divides them both?
5 or 4.
4. So the top becomes 5 and the bottom becomes 1 because 20 divided by 4 is 5. 20 divided by 4 is 5. 4 divided by 4 is 1. There's your answer.
Right. Okay, that was easy. These common multiple.
Let me grab
Would it be
this.
4?
The 4 goes into
4 times 6.
Yeah, this one's more complicated. They didn't give you a nice starter question for this one. They kind of jumped right into level 2 difficulty.
Where would it be 2?
So there's two concepts. There's least common multiple, and then there's like greatest common factor, and they're sort of related, but this one is a little bit disguised. So we're looking at 24x squared. And then this one on the right, you actually can factor an 8x out of both. So you get x minus 2. So the least common multiple is you build something that contains both of these in it. So like, for example, 24x squared, you can get from the 3x by multiplying by 3x. 28 times 3 is 24. X times x is 24x squared. Do you see that? And then the x minus 2 is missing from over here. So if you multiply that by x minus 2, you get x minus 2.
So it would be 24x squared x parentheses times x minus 2, maybe?
Yes, and this will make more sense. Yes, this is the correct answer, but this will make more sense when we do an adding and subtracting problem where they're not the same.
Okay.
All right, so let me grab this one. Unfortunately, these are not in context, so they're a little bit tough to talk you through, but we'll show you here.
It's okay.
There we go. All right, so I'm sharing my screen now. X squared minus 25 is a difference of squares. So what would A be and what would B be in this case?
5 and 1.
So A is x because you square x to get x squared, and B is 5 because 5 squared gets you back to 25. Like it's like figuring out what's squared minus what's squared.
Right.
Okay, so the reason that's useful is this becomes x minus 5, x plus 5. Okay, and then to determine the least common multiple here, you try and figure out like what is missing. So like this one on the right, what is it missing? It's missing an x minus 5. No, an x minus 5. Like it already has these are already the same, but it's missing this right here. So you would want to have, I'm sorry, I underlined the wrong thing. This is just not a great way to explain this. The x minus 5 and x minus 5 is the same in both, so you need to add the x plus 5 to the one on the right. So in short, I guess this is your least common multiple. Hopefully there are some questions coming up where you actually have to add and subtract so we can make this clear.
Okay. Okay.
All right, I'm going to grab this question. We'll snip it in. So again, you're going to have to factor. Why isn't this copy? All right, share screen. Okay, so share screen here. You're seeing my screen. We have to factor both of these. So let me try again to explain this difference of squares. The form is a squared minus b squared. So you have to figure out what's squared. You have to figure out what goes in each of these positions to get you back to the previous line. So it's like on the right here, what squared gets you back to 16?
4.
4. And that's your b. Your b is 4. That's this one over here on the right. What squared gets you back to 9?
3.
Okay, and then the x goes there. So your a is 3x. So this a squared minus b squared always becomes a minus b, a plus b. And once you know your a and your b, you just literally write them together. 3x minus 4, 3x plus 4. Okay, and that takes care of that first one. The one on the right here, we're going to use a guess and check approach. So we need all the factors of minus 4. Factors of minus 4 are minus 1 and 4, and then 1 and negative 4, and then 2 and negative 2.
No.
Now, since we already have like an x minus 4x plus 4, I'm gonna try those first. So I'll go like minus 1 plus 4 here and see if that's right. And the way you do this is you FOIL to check, but you only FOIL the outer and the inner. Do you remember FOIL from a previous time in math?
Yeah.
So you check the outer. The outer is 12x. The inner is minus 1x. And that doesn't work. That doesn't get you back to the 1x. So that means it's not right. So the next thing you do is you actually just switch them. You just switch the this isn't all that good. You go plus 4 minus 1. So when you do the outer, that's minus 3x, and when you do the inner, that's 4x. And when you combine those, you get 1x. Okay, so that gets you back here. So in short here again, just to summarize, like you factor both of these with factoring techniques, and then you look at them and you say, well, what does one have that the other has, or what do they both have? So they both have a 3x plus 4. Do you agree with that?
Yeah.
This one has a 3x minus 4 on the left, but this one does not on the right. So that has to go with it as the LCM. And then the x minus 1 over here is missing from the one on the left, so it has to be included as well. So you factor to figure out what the factors are, and then you say, well, what does each one have? What is missing? What is missing?
That is too much.
Hopefully that's the last one on this sort of like least common multiple, and then we can move on to maybe another topic here.
Yeah, that'd be great. But yeah, my teacher said that the next, so like we're skipping a chapter, we're gonna go to like chapter 9, and it's harder than this one. I guess
Well,
like it's worse than this one, so that's fun.
yeah, well, we'll see. I mean, sometimes harder doesn't mean it's more work,
Right.
and sometimes there's some shortcuts that we can use. But go ahead and share your screen whenever you're ready, and we'll see. Maybe we can click through a few more. Yeah, so if you don't mind, just click past this. Click past this. So let's go back to that previous one there. Do you see how the one on the left has a 2x? Oh, no, you right there, you were good. Go to the one before it. I don't know where you,
This one?
nope.
Oh, 14?
Yes, okay. So this one we can sort of talk to. Is this the last question of this?
Yeah.
Okay. So the least common multiples, do you see how the one on the left has a 2x and the one on the right has a 2x?
Yeah.
So that the least common multiple contains 2x for sure. Right. And so let's go ahead and enter that in as your first part of this. Okay. And then what does the one on the right have that the one on the left does not have?
X minus 5.
X minus 5 in parentheses. All right, so just for maybe for my sake, why don't we have a choice here for the last 10 minutes of this particular hour. We could probably finish this up, or we could go back to the previous one and finish up. If you're asking me, I would rather go back to the previous.
Yeah, I was gonna say let's go to the previous one since I have less problems. Hello, what's going on? That is.
This one looks
Okay.
good. All right, so let me snip this in, and a lot of factoring here, but this is the fun one where you kind of cancel at the end and things work out nicely. So let me share my screen. All right, so top left here, two numbers that multiply to 18 but add up to positive 9. So 1 and 18, 2 and 9, 3 and 6. Do any of those add up to positive 9?
3 and 6.
So the top becomes x plus 3, x plus 6. Okay, so will you try to factor the bottom left here? Two numbers that multiply to 8 but add up to positive 6.
4 and 2.
X plus 4, x plus 2. Now, we're going to flip these on the right. So now it's negative 8. I'm going to do this one on the bottom first because it goes up top. And we want positive 2. So it could be like negative 1 and 8, 1 and negative 8, negative 2 and 4, 2 and negative 4. Do any of these 4 add up to negative 2? I'm sorry, positive 2. We want positive 2 this time.
Negative 2 and 4.
So that's x minus 2, x plus 4. And then negative 18 is the last one. We want them to add up to negative 3. Minus 1 and 18, 1 and minus 18, minus 2 and 9, 2 and negative 9, negative 3 and 6, 3 and negative 6. Do any of those work?
3 and negative 6.
Yep, so we got x plus 3, x minus 6. Okay. All right, so now tell me what you see that cancels in the top and the bottom.
X plus 3, x plus 2, and x plus 4.
So I must have made a mistake because I don't x plus, okay, I just see the x plus 3 and the x plus 4. Is that what you said? I'm sorry if I misspoke, but
Oh yeah, I think I probably said x plus 2, but yeah,
Okay.
that's right.
So the things I'm boxing in go into the top, and then the things that I'm boxing go on the bottom up here in your answer.
Okay.
Let me know when you're ready for the x not equals parts.
Okay. Okay, I'm ready.
So what I wrote down on the bottom here, and I think hopefully you can see this, is the ones that cancel. We canceled an x plus 3, and we canceled an x plus 4. You set those not equal to 0, and that produces -3 and -4. So the ones that cancel are always what become the not equal to's.
Mm. Cool.
All right. So whenever you're ready, go ahead and share the next problem you want us to look at together. And
Where is it? Okay, there it is.
lovely. Another one of these
Lovely.
long ones. Yeah. So maybe we'll get them both done. I'm not sure. All right. So let me share my screen, and lots of factoring. So I will, the one up here is x minus 8, x plus 5. And then the one on the bottom is x plus 10, x minus 2. Now I would like you to factor one or the other. It doesn't matter to me, but could you choose one, top or the bottom here, and see if you
I'll
can
do the
factor?
bottom.
Okay.
Um. mm,
The two numbers that multiply to 20 but add up to 12.
2 and 10.
2 and 10. So that's x plus 2, x plus 10. The top one here is 40, and we want them to add up to 13. So you see me make this list for a while now. And eventually you get down, oh yeah, one of those works. X plus 5, x plus 8. All right, so now tell me what you see that cancels and does or not here. What do you see?
X plus 5 and x plus 10.
Yeah, and then, there's 3 not equal to's though. Let me check here. Is there any option like DNE if it doesn't work, or?
I don't know.
Okay. I'm just checking to see that these are all right. They look really good, but yeah, because I mean the x plus 10 definitely cancels, but I'm not seeing any others. So what to do here. Because you can see like you're only going to get -5 and -10 here, but not a third one. But you could definitely start putting the stuff that's in the top into the top there for you.
It says it's right, so I'm guessing that
Perfect.
there's not another one.
All right, well, let's go with that.
Okay.
All right, so probably this is where we'll have to stop for now. If you want, you can share the last question. I'll snip it in so it's ready for next time.
Okay.
Actually, this one is pretty fast, so we will do this and close out the hour. So let me share my screen, and we'll just do this one real quick. Okay, so the important thing here is when you divide, you change the order, you flip it. And we did one like this earlier where you actually we combine the numerators. So 32 times 8 is 256. X cubed and x to the 4th is x to the 7th. There's one y there. And then the bottom, it becomes y to the 15th because you add those together. And then we talked about how you can only cancel stuff if it's the same on the top and the bottom. So there are one y up here and 115 down there, so that's 14 total. And then why does it show that x cannot equal? Really odd. Nah, I don't understand that at all. But so to me, this is the correct answer. So
Okay. I will put that in then.
all right. I will see you in about 10 minutes. Please use that other Zoom link, and I'll see you shortly.
All right. Awesome. See
Thank
you in a
you.
bit then.
Okay, bye now.